Hello guys, welcome to my channel. Well, actually, this is not my channel, but this is my class channel. So, let me repeat. Welcome to my class channel.
My name is Nurfaizi Yahya is Zureta. People often call me Faiz. I'm from Physics Department, Malang State University.
Today, I want to tell you people about oscilloscope. Well, a traditional oscilloscope works in almost exactly the same way as a traditional television. In a television, electron beams are made to scan back and forth across a screen coated on the back with special chemicals called phosphor. Each time the beam hits the screen, it makes the phosphor lights up. In less time than it takes to blink an eye, the electron beams sweep across the entire screen and build up the picture you can see. Then they do it all over again, so you see a moving picture instead of a still one. In an oscilloscope, the electron beams works the same way, but instead of building up a picture, they draw a graph. Oscilloscope. The main purpose of an oscilloscope is to graph an electrical signal as it varies over time. Most oscilloscopes produce a two-dimensional graph with time on the x-axis and voltage on the y-axis. What can be measured by oscilloscope? First, oscilloscope can measure frequency and period. Then, oscilloscope can measure rise and fall time of the signal. Oscilloscope can either be analog or digital. Analog oscilloscopes use an electrical beam to directly map the input voltage to a display. Digital oscilloscopes incorporate microcontrollers which sample the input signal with an analog to digital converter and map that reading to the display.
I will explain how to use oscilloscope. For the example, an oscilloscope will be used to measure the frequency and voltage of a signal. When measuring a single source, attach the lead to the channel 1 terminal and select channel 1 mode. The group of trickle controls on the right of the oscilloscope is used to ensure that the input signal displayed correctly on the oscilloscope. Ensure that the trickle hold-off button is set to auto, and make sure that the source channel is set to the same channel that the input source is connected, in this case to channel 1. The VAR dial is used to vary the gain of the input signal. It should be set to calibrated mode by turning the dial clockwise until the click is heard. The set of controls on the left of the oscilloscope vary the position and scaling of the vertical or voltage axis of the signal displayed on the oscilloscope screen The vertical position dial is used to change the position of the signals display relative to the grid. It does not alter the actual input signal. The volt or division dial changes the scale of the displayed signal voltage and can be used to ensure that the entire range of the signal is displayed on the screen. To calculate the peak-to-peak voltage of the signal, the number of divisions between the maximum and the minimum of the signal must be counted. This value multiplied by the volt per division settings gives a peak-to-peak voltage. In this case, there are 5.6 divisions multiplied by a volt per division of 1 volt, giving volt peak-to-peak equals to 5.6 volt. With this alternative scale, there are 2.4 divisions multiplied by a volts per division of 2 volt, giving volt peak-to-peak equals to 5.8 volts. The difference in the two readings is due to uncertainty. Always choose the scale appropriately. The set of control in the middle of the oscilloscope vary the position and scaling of the horizontal or time axis of the signal displayed on the oscilloscope screen. The horizontal position dial is used to change the position of the signals display relative to the grid. The time per division dial changes the time scales of the displayed signal. It is used to ensure that an entire cycle of the signal is displayed on the screen. To calculate the period of the signal, the number of horizontal divisions between successive crests of the signal must be counted. This value is multiplied by the time per division settings gives the period of the signal. In this case, there are 3.4 divisions multiplied by a time per division of 10 microseconds, giving t or time equals to 34 microseconds. From this, the frequency can be calculated as the inverse of period.
And now you have more information about oscilloscope, right? Well, I hope you people enjoyed the video, and I also hope this video will benefit all the viewers. Thank you for your nice attention, and again, I hope you enjoyed the video. I'm sorry if I have any mistake. I am Nurfaizi Yahya. See ya.